All right, we're gonna try. All right, we're gonna try. All right, we're gonna try to scare Salil again. We have two people. One hiding in each closet. You guys want to come out for a sec? Just say hi.
Hello. Hi.
Yo, hey, Salil. Today is. I don't know, what day is today, Salil?
I don't know, Michael. I lost all track of time.
Yeah, this is a weird thing at Shad where like every day is so unique, such an adventure that like you don't really keep track of time because you always never really know what's going on until you do it. Welcome to Shad.
We're at the veterinary school. We were here yesterday, and now we're here again for a lecture on toxicology.
Toxicology. The lecture went really well. We learned a lot about toxicology. Now we're going into the toxicology building, and there are going to be a bit of photos in 3, 2, 1. Now it's the time we've been waiting for. We're going to the synchrotron. I think this might be, for me at least, one of my favorite parts of Shad. What do you think, Eddie?
I think it's going to be very good.
It's going to be
great. We all bet a lot of points on this.
How many points did you bet?
100 out of 100.
100 out of 100? Oh, you want to be in it?
Hi.
What do you think about the synchrotron?
It's awesome. Yeah, I'm excited. I have no idea what we're doing, but I'm excited.
So we are here, but we're locked out. Yeah. But everyone's still happy.
Yay!
I'm sad.
Except for Willie.
I'm pretty sad we can't get in yet.
Oh man.
All right, we're inside. Marn, how you feeling?
I feel very excited. It's going to be my first time using the Beamline. I have no idea what we're going to be doing. So yeah,
It's gonna be great. Jump dad? Jump dad? Oh yeah. Jump dad. So the next video is going to be the sample that we're going to be testing out at the synchrotron, the Canadian Light Source synchrotron, and it's part of a plane engine, more specifically the part of a turbine. Notice the rust and the kind of discoloration around. So here's what our instructor told us. He said that mostly the inside is made of probably nickel, because that's what most planes are made out of. It's probably some sort of alloy. Our experiment is going to be designed to figure out what compound, what alloy makes up that plane part, what's the chemical composition, and see what each color is and what element it represents. And so the really cool thing is that this is something that probably hasn't been done before. When engineers design a plane, they simply just use parts to fulfill the requirements so that the plane will fly. But using a synchrotron is actually really expensive for professionals. But as students, we have access to this technology. The potential, it's the idea that we may be doing something that no one else has ever done in the world before. That's pretty cool. So we are going to be collecting data using the IDEAS beamline. There's going to be a single wavelength being used. That's going to be an X-ray. And the energy of the photon beam is 10.5 kilo electron volts. But the question is, how does a synchrotron work? Let's take a look. How does a synchrotron work? Well, imagine you got this like conductor and a resistor, positive, negative over here, and you have a container. Now this container is airtight. It's actually a vacuum chamber, and here you got electrons passing through. So here you have a slit, and if you positively charge this container, charge of +1 volts, the electron, which is negatively charged, will be attracted to the positive charge, and so it'll travel this way. And if we magnify this tube, the electron going through, when it gets positive, it attracts, and then once it gets here, it repels when it's negative. And this continual alteration causes acceleration. And that's kind of how an electron gun works. It will be 1 electron volt because, well, you have 1 electron here multiplied by 1 volt. You guys may be wondering, why are we using a particle accelerator? Well, to use an analogy that our instructor gave, imagine you have a chicken and you want to find what's inside the chicken. And so what a particle accelerator would be like is throwing a chicken at a wall, and from that you're gonna look at what gets deflected off the wall and figure out what's in there. Before that all happens, people are gonna have different theories, but it's only until you test it out where you can actually prove what happens. Maybe you'll see some chicken organs flying out. It's stuff like that. The problem is that if you just have a linear particle accelerator, in order to have more power, it needs to be really long, but it's hard to make a really long accelerator. So the idea is that instead of having the linear one, what if you have a circular one and just shoot electrons in a circle? Going back from the analogy back to the particle accelerator, what if you have an electron and you spin it in circles really, really fast? That is what a synchrotron is. A synchrotron is a particle accelerator in a circle. These are both particle accelerators. This is a linear one, this is a synchrotron. Now, from the first one, we have electrons simply just going in a straight line, whereas that's hard because it's only limited to how long your particle accelerators. Whereas if you have a synchrotron, you're shooting electrons in a circle and it's going really, really fast, and then when it turns, a funny thing happens. Light gets emitted, and it's not visible light but rather X-rays. And that is what we're going to be measuring. So, the beamline that we're using is going to analyze the light, which is not visible light, but rather X-ray light. And so now we're going to be taking a look at what the beamline actually looks like.
This is where we actually do the experiment. That's the beamline where we condition the beam. So we focus it, that's the monochromator that I was telling you about is located.
Hey, we just got all our badges.
Look at my forehead.
My face is very weird.
That does look like huge. Oh, I see though.
So fancy. Yeah, look at how shiny my...
So today we just got out of the synchrotron and we were mostly learning the science behind the particle accelerator, the processes, and tomorrow we're going to actually be performing the experiment.